Hello, students, and welcome to our topic, solving equations. What we're going to be doing today is instead of just one-step equations, which we had in our first topic, we are now going to have two, maybe even three or four-step equations. And so this will be a general review slash teaching of how to solve equations. So as a quick review, an equation is a mathematical sentence stating that one expression is equal to another expression. Remember that an expression might look something like 2 parentheses x plus 3, where there is no equal sign involved. But when we have an equation, it might look like 2 parentheses x plus 3 is equal to 6x, where we actually have an equal sign in there. So expressions, no equal signs, equations, we have an expression on each side of an equal sign. All right, and then a solution to an equation is any replacement of the variable that results in a true statement. So when we solve an equation, what we are solving for is the value of a variable that makes the equation true when we plug it back in. So now steps for solving an equation. If possible, we want to simplify both sides of the equation. So if possible, simplify the expressions on each side of that equation. And what does it mean to simplify? Well, we use that word a lot in mathematics, and it means a different thing in most contexts. But generally speaking, when we say simplify, we mean to make it look as nice as possible. So in this case, simplify means to distribute anywhere that you can do so. Okay, so on both sides, if there's any distribution to be done, do that distribution. And then we're going to combine like terms if any exists. Where remember that like terms are terms that have the same variable to the same power. So 3x and 5x would be like terms, for instance. You could add those together, for instance, to get 8x. But 3x and 5y, those are not like terms because they have different variables. Okay, so they are only like terms if they have the same variable. Oh, and I should be clarifying here that if we don't have a variable attached, so if we just have numbers like 7 and 9, those are like terms because no variable means the same variable, right? If they both don't have a variable, then that variable is the same. They just both don't have one. All right, so first we simplify both sides of the equation. Then the solving steps after we simplify are always going to be the same. We're going to move all terms with variables to one side of the equation. So move all terms with variables to one side of the equation using addition or subtraction. And while we're doing that, we're going to move everything that doesn't have a variable to the other side of the equation. All right, so on the other side, okay, move everything else to the other side. So the idea here is we want to collect the variables on one side and push everything that's not the variable we're solving for to the other side. When we do this, all the variables will come together. There's just going to be one variable in each equation, by the way. It's going to be the letter x for us in this lesson. So we want to get all those x's together to just get one variable term. And then what we're going to do is make the coefficient of the variable 1. And remember that the coefficient of a number or a coefficient of a variable is the number in front of that variable. So if we have 3x, the number 3 in front is the coefficient. Okay, so coefficient, just fancy word for number in front of variable. Coefficient. All right, and then answers can always be checked by plugging them back in to the original equation. So we will do that on the first problem here, but as a reminder, just because I do not check all of my answers on here, that does not mean you should not check all your answers when you are solving for yourself. You need to keep in mind that I have a key next to me, so I can verify my answers are right by just looking at my key. Whereas you guys, when you're solving these in your homework or in other places, you don't have that key. So plugging back in is how you ensure that you're getting to the right place. All right, so now let's go ahead and solve some stuff. Number one, we have 5x plus 2 is equal to 57. Our goal is to get all of the x's on the left and everything else on the right. So in order to get everything else to the right, I'm going to subtract 2 from both sides, which will give me 5x is equal to 55 because those 2's on the left side add together to be 0. So that is the additive identity. So they cancel each other out, so to speak. They add to be 0. And then now that we've got all the x's on the left and all the numbers, everything else on the right, now the next step is to make the coefficient of the variable 1. So to make the coefficient of the variable 1, we divide both sides by whatever is in front of that variable. So whatever that coefficient is, in this case 5, we divide both sides by 5, and that gives us that x is equal to 11. So then we can go ahead and check our work. So over here, we can do a check step where we take the original equation and we plug 11 back in. So 5 times 11 plus 2 is supposed to equal 57. That left side does in fact equal 57 because 55 plus 2 is 57. And so the fact that we get a true statement means that our solution is in fact the correct solution, which means we can move on with our lives and not have to stress about it. But if you don't check, you don't know for sure. So please remember, always check your answers in these problems. All right, number 2, very similar question. We just have a negative sign involved. So we have negative 6x minus 5 equals 1. I want to get the x's on the left and the numbers on the right. The x's are already on the left, so all I have to do is move these numbers, this plus 5, over to the right, where I am doing plus 5 because the operation I see is a minus 5. So I want to do whatever will cause this negative 5 to cancel out and add to be 0. So after doing that step, I'm left with negative 6x is equal to 6. I can then go ahead and divide both sides by a negative 6, because since the coefficient of x is negative 6, I divide by that negative 6, and that gives me x equals negative 1. Now, you should go back, plug negative 1 in, and check your answer, but because I have confidence here, thanks to my key where I worked this out earlier, we're going to move on to number 3. Okay, for number 3, we have 5x plus 3 equals 2x plus 15. This is the first one where we have to move the x's as well as the numbers. So what we want to do is first get all of the x terms on one side. So I'm going to move all of the x's to the left. So what I'm going to do is subtract 2x from both sides. But notice that when I do that, I don't just write the 2x anywhere on the screen. I specifically write 2x underneath the 5x. That way they create this nice stack where I don't have to think about what to do with the 2x. It is a like term with the 5x, so by writing it directly underneath the 5x, I can then just add vertically to get 5x minus 2x is 3x. The plus 3 next to it stays the same. Oops, sorry about the keyboard there. So that plus 3 stays the same. On the right side, 2x and negative 2x are inverses, so they cancel each other out. And we just have this positive 15 off to the side. All right, so now we have all the x's on the left. We want to now move all the numbers or the constants to the right. When I say number, by the way, and I say constant, please keep in mind those are the same thing. A number is a constant because it does not change. But when I say variable, I'm talking about the letters, the x's and the y's, because they could represent anything. All right, so to move the 3 to the right, I'm going to subtract 3 because we see addition by 3 there. Then I get 3x, no more numbers there, the 3's cancel. 3x is equal to 12 on the other side. And so one last step, I just need to divide both sides by 3 here because the coefficient of x is 3. So I divide by 3 and I get x is equal to 4. Now keep in mind, whenever I'm dividing both sides by the coefficient of x, what I'm actually doing is making it so that I have 1x on that left side. We just don't write the 1 because 1x and x we know are the same thing. But we want x to be all alone, meaning have a 1 in front of it and nothing else. That way we know what the value of that 1x is. Okay, so if we still had a number in front of it, such as 3x equals 12, we don't actually know what x is yet. We know what 3x is. But we don't want to know what 3x is. We want to just know what x all by itself is. All right, you try for the next one. So if you have not tried any of these yet, please pause the video and give it a chance. All right, hopefully you pause there. So what we're going to do now is 6x minus 5 equals 7x, or 7 plus 2x, I should say. We want to get all the x's to the left. So what I'm going to do is subtract this 2x from both sides. Because whenever you want to move something from one side of the equation to another, you do the inverse operation of whatever it has. So on the right side, these two x's cancel. And so I'm going to be left with 6x minus 2x is 4x, negative 5, nothing changed, and 7 stayed alone. Where again, I want to point out that when I write the negative 2x on both sides, I write it directly under the 2x here and directly under the 6x here. That way I'm automatically combining like terms by adding vertically. I do not want to write the negative 2x underneath the 5 because then I might think that those are like terms and accidentally combine them when I'm not allowed to. So just make sure x's go under x's go under x's, and numbers go under numbers. So in this next step, I want to move the 5 to the right. So in order to do that, I'm going to add 5 to both sides. Where again, notice that I write the plus 5 directly underneath the minus 5. Those 5's add together to be 0, so they are inverses and cancel each other out. We get 4x is equal to 12, and we divide both sides by that coefficient, which is the 4, and we end up with x is equal to 3. All right, so now you might have been wondering, I keep saying that we want to move the variable to the left. And that's not wrong, but it's not technically necessary. Okay, technically we can move the variable to either side and we'll get an equivalent answer. So what I'm going to do now is this same problem, but I'm going to move the variable to the other side instead, just to make sure we're clear that this doesn't change what happens. The answer will just look backwards. So we'll still get x equals 3, it'll just be written the other way around. So if I follow all the same steps, but I do them the other direction, so if I subtract 6x from both sides, instead of subtracting 2x, that'll move all the x's to the right side. So I'll get negative 5 is equal to 7 minus 4x, where these 6x's canceled. Then I'll move the 7 to the left by subtracting 7 from both sides. On the right side, those 7's will cancel out, and we'll be left with negative 12 is equal to negative 4x. And so now, instead of dividing by a positive 4, I end up dividing by a negative 4 on both sides. But notice that my answer is still going to be 3 is equal to x, which is the exact same thing I got before, it's just flipped. So whenever I say to move everything to the left, really I just mean to get everything, all the variables on one side and all the constants on the other side. But it's up to you which direction you prefer to move them, because we have the same answer either way. Okay, I personally prefer to write the variable on the left, but there are times where that's not convenient, and so sometimes I do in fact write it on the right instead. So it's all based on context. All right, number 4. Now we have to do a little bit of simplifying before we can solve. So we have 6x plus 1 minus x equals 2 times 10x minus 1. So what our directions told us is that if we can distribute, we want to do that first. So on the right side, I'm going to distribute this 2 to get 20x minus 2, because I multiply the 2 by each thing inside. And right now, I'm going to leave the left side alone, 6x plus 1 minus x. So all I did in that step was distribute the 2. In this next step, now I'm going to combine like terms. So on the left side, 6x minus x is going to give me 5x, and I still have that plus 1 there. All right, where all I did was I took the two like terms, 6x and negative 1x, and I put them together to get 5x. And now this looks just like the problems on the previous slide. So we only do this simplification to make it look like the same problems we've been working with. After you distribute and combine like terms, every problem, in this case with linear equations, essentially looks the same. All right, so now we're going to start solving. I want to get all of the x's to the left, so I'm going to subtract 20x from both sides. When I do that, on the right side, those 20x's cancel. And on the left, I get negative 15x plus 1. On the right side, I just have a negative 2 left. Now I'll move that 1 over to the right side. That'll leave me with negative 15x. The 1's cancel. So negative 15x is equal to negative 3. And my last step is just to make the coefficient of x1. So I divide both sides by a negative 15. And I'm left with x is equal to negative 3 over negative 15. The fractions both have a negative. There's a negative in the numerator and denominator, so those cancel. And the fraction simplifies to just be 1 over 5. So we get a positive number because a negative divided by a negative, and it's 1/5 because 3 and 15 are both divisible by 3. So if right here we divide the top by 3 and divide the bottom by 3, we end up with just 1 over 5. All right, number 5. Again, we have some distribution to do. 4 plus 7x equals 7x plus 1. So, or 7 times x plus 1, I should have said. So we'll distribute that 7 to get 7x plus 7. So we have 4 plus 7x equals 7x plus 7. When I start solving, I'll subtract 7x from both sides to get everything on the left. But when I do this, I get 4. These 7x's cancel here and they cancel there, so I get 4 equals 7. That does not feel right. Okay, so what we have to do now is realize that this is not bad, but it's also not good. So what we just got is a false statement. And when we get a false statement, that means that there is no solution. Okay, what that means is that we had a contradiction or an inconsistent equation. Okay, so we had, or 4 equals 7, because that is false, we say this is a contradiction. So the equation was inconsistent. Remember, there are 3 types of equations we care about. There is consistent, which might be conditional or might be dependent. And then there's inconsistent. So we either get one solution, we get infinitely many solutions, or in this case, we get no solution. Okay, so when you get a false statement like we did here, you get no solution. And so there's no more work to be done. We just don't get an answer. All right, number 6. We have 2 parentheses 3 plus 4x minus 6 equals 48. So again, we need to start by distributing. We get 6 plus 8x, and then we have minus 6 equals 48 here. We can then combine like terms. So the 6 and the negative 6 come together to be 0. So we just get 8x equals 48. And again, all I'm doing there is combining like terms. 6 and negative 6 add to 0, so they just cancel each other out. And now we can divide both sides by that coefficient of 8 to get that x is equal to 6. All right, so that one, not too bad. A little bit weird, though, to have things cancel out in the middle of the equation, but you'd be surprised. That actually happens quite often. Okay, number 7, now we have a lot of distribution to do. So we have 13 minus 2x plus 2 in parentheses. What is important to realize, and this is actually a grievance I have with mathematics as a whole, is we're very lazy in math. So 13 minus 2x plus 2 is really 13 minus 1 times 2x plus 2. And then on the other side, we leave it the same, 2 times x plus 2 plus 3x. So all I did there is I put a 1 in front of this set of parentheses, because when we have a negative sign there, really it's a negative 1. We just don't write the 1 because the 1 doesn't change any values. But just like on the right side, we're going to distribute this 2 to both places. On the left side, we need to distribute a negative 1 to both places. Okay, so it's just important to realize when there's no number there, there actually is a number. It just is a 1, and so we tend to not write it. So on the left side, when I distribute the negative 1, I'm going to get negative 2x minus 2. And on the right side, when I distribute the 2, I'm going to get 2x plus 4. But I still have the rest of the problem around it. So I have the 13 in front and the plus 3x in the back. All right, so just be careful when you distribute that negative sign. Both things on the inside change signs, and they both become negative in this case. But specifically, we're multiplying a negative 1 times both things. All right, so now we can combine like terms. On the left side, 13 minus 2 gives me 11. So I have negative 2x plus 11. And on the right side, 2x and 3x combine to be 5x, and we have a plus 4 there. All right, now I want to get all of the x's on one side. In this case, just to remind you that it's an option, I'm going to move the x's to the right side. So instead of subtracting 5x from both sides, I'm actually going to add 2x to both sides. Okay, this cancels out the x's on the left. They add together to be 0. And so I end up with 11 is equal to 7x plus 4. I can then go ahead and subtract 4 from both sides to get all of the constants to the left. I now have 7 equals 7x. And then last step is just to divide both sides by 7. And when we do that, we're going to get 1 is equal to x. Where notice this time I have the x on the right side. Nothing wrong with that. Okay, we still just have x is equal to 1, but we would read it in this case as 1 equals x. But notice that when you have equality, you can say the statement either way around. 1 equals x or x equals 1, exact same statement. All right, 2 more. If you have not tried to pause the video yet and try for yourself, please take advantage of this opportunity to pause the video. All right, hopefully you did so. So the you try right here is actually going to give us an interesting solution. We're going to start by combining like terms. So on the left, 5x minus x is 4x, and on the right, x plus 3x is 4x. So technically I can stop here and say that these are the same, so we have a dependent equation, but it helps a lot of students to actually try to solve. So if we subtract 4x from both sides, we end up with 0 equals 0 because everything cancels out. And so what we get, very similar to question number 5, but the opposite, we get a true statement. Okay, when we get a true statement, that means there is infinitely many solutions. Specifically, what this means is that no matter what you plug in for x, you will get an answer. So every x is a solution to this equation. And so we can say here that this is either an identity where we had 4x equals 4x. Okay, so key giveaway that's an identity is that you have a true statement, or just the fact that you have the same thing on both sides of the equation. So we call this being an identity or a dependent equation. Right? And so the key is to recognize that when you have a true statement on both sides without having solved for x, that means that you are in an identity or a dependent situation, meaning every value of x is a solution, so we have infinitely many solutions. So it's the exact opposite of what number 5 was. All right, number 8, this is our last one, and it's our messiest. So we have fractions all around, but we're going to proceed as if they were not fractions to start. So we have distribution on the right side. I want to distribute that 1/4 to the x and the negative 2/3. That's going to give me 1/4 x minus, and when I multiply 1/4 times 2/3, I multiply the 1 and the 2 on top and the 4 and the 3 on bottom. So I get 2 over 12, which is actually the same as 1/6. So instead of writing the 2 over 12 there, I'm going to go ahead and delete that and put 1/6 in its place because we always want to reduce fractions to make our lives easier as we solve these equations. Now the left side stayed the same, 1/3 x plus 5 over 2. And so now we're in a situation, let me make that look a little nicer there, move that down. Now we're in a situation where we have fractions everywhere, but we don't have to distribute anymore. So technically speaking, we don't have to care that there's fractions. We could go about all the same solving steps. I could subtract 1/4 x from both sides, subtract 5 over 2 from both sides, and then divide by the coefficient. But it just looks better if we clear the fractions. So mathematically speaking, we don't have to. And oftentimes, people who are very comfortable with fractions actually prefer not to. But in our case, most students I work with prefer to not have fractions in the problem. So what we can do is make a little note here that to clear fractions, and by clear, I mean get rid of any denominators, okay? That way we only have integers. So to clear fractions, we are going to multiply the equation on both sides by the lowest common denominator. So LCD right here, lowest common denominator. Okay, in general though, we will use the phrase LCD. So now the lowest common denominator is the least common multiple of all of the denominators. So what we have to do is look at the denominators and see what is their least common multiple. So we have a 3, a 2, a 4, and a 6. So between 3, 2, 4, and 6, we want to know what is the smallest number that is divisible by all of these numbers. That number is going to be 12. Okay, the way you find out what the least common multiple is you take all of the prime factors of these numbers and you put them together. So 3 and 2 are already in their prime factorizations because they're already prime numbers, but 4 is 2 times 2 and 6 is 3 times 2. So if I multiply a 3 and a 2 together, that will give me 6. That means I don't need to include this 6 when I find the least common multiple because 3 times 2 already gives me 6, so 6 is covered. But 4 is 2 times 2. So there's two 2's in there. And so because 4 is 2 times 2, one of those 2's has not been accounted for yet. I accounted for one of the 2's already because I started by doing 3 times 2 on the left, but I still need to multiply by that other 2. So 3 times 2 times 2 gives me the 12, and all I actually did there was find the least common multiple by taking the prime factors and putting together all of the unique digits. Okay, so now if we take that information and we multiply everything in this equation by 12, that 12 is really a 12 over 1, mind you, because we're multiplying by fractions here, so a lot of times it's convenient to think of that 12 as being over 1. We are going to multiply that times everything in this equation. Okay, we're going to distribute it to both sides of this equation. When I multiply 12 times 1/3 x, that is going to give me 4x, because 12 divided by 3 is 4. When I multiply 12 times 5 over 2, 12 divided by 2 is 6, and 6 times 5 gives me 30. When I multiply 12 times 1/4 x, 12 divided by 4 is 3, so I get 3x. And when I multiply 12 times negative 1/6, 12 divided by 6 is 2, so I get negative 2. All right, and then now that we have those fractions gone, now solving is just as easy as all the other ones, where we just want to get the x's on the left by subtracting 3x from both sides. That's going to give us 1x plus 30 is equal to, those 3x's cancel, so I just have negative 2 on the other side. Then I'll move the 30 to the other side by subtracting it, and we end up with x is equal to negative 32. And that, because x is already by itself, is our solution. So now, the only things in here that were not covered in explicit detail, because they are information you were expected to know from before, is how I got that 12, so that least common multiple. So if you have questions about that, please don't hesitate to ask. We can do a little side lesson in class if you're struggling with that. But then we actually already covered how to know if there's infinitely many solutions or if there is no solutions in topic number 1. So if you don't recall what a contradiction, or in this case, an inconsistent equation is, or if you don't recall what an identity or dependent equation is, I encourage you to go back to the first video, equations and their solutions, and look that over again. But I hope you guys enjoyed this video, and I'll see you for the next one.